In this video, the method to draw a normal on any point of a circular shape, and the formation of rainbow will be explained in a beautiful animated way. The explanation will be very basic to the level of secondary school students. Let's start with the definition of a normal. The normal on any point of a circular shape is a line at 90 degrees to the tangent at that point. The term tangent means a line that cuts the circle only at a single point as shown in the figure. For explanation point of view, let's consider 3 points A, B and C on the circle. The dark red lines are the tangents on these 3 points. The black lines drawn at 90 degrees to these tangent lines at points A, B and C are called the normal on these 3 points of the circle. Now let's discuss about the formation of the rainbow. In rainbow formation, understanding of raindrop and sunlight is important. The shape of the raindrop while pulled by the earth is approximately as shown in the figure. The sunlight is normally considered as white light, which is the mixture of million of colors. But for simplicity we will just consider 7 colors in this video. These 7 colors are VIBGYOR: violet, indigo, blue, green, yellow, orange and red. The raindrop acts like tiny prism. The function of the prism is to disperse white light into its constituent colors. Let's focus at point A. The procedure to draw a tangent and a normal on any point of the droplet shape is exactly the same as explained in the case of the circle. So, let's draw a tangent and a normal on point A of the droplet. 2 phenomenon will be happened at point A. Number 1, the dispersion of light. Number 2, the refraction of light. During the dispersion of light, the light will be dispersed into 7 VIBGYOR colors. During refraction, the speed of light will be reduced while entering from air to water medium. Due to the reduction of speed of light, the light will bend towards the normal as shown in the figure. Hence, the angle of refraction 20 degrees is lower than the angle of incidence 30 degrees at point A. The change of speed of light in different mediums is explained in detail in our another video named Optical Density and Refractive Index. The link of the video is given in the description below. Next let's focus at point B. At point B, there is only one medium and that is water. So, speed of the light will remain same, before and after the collision. The second aspect in the collision at point B is the critical angle. The critical angle is the property of a medium and for water the critical angle is 49 degrees. As a rule of thumb, when the angle of incidence becomes greater than the critical angle then full reflection of the light takes place, and light does not refract in this process. The same case exists at point B of the droplet. At point B, the angle of incidence with the normal is 50 degrees, which is greater than the critical angle of the water. Hence, full reflection of the light will take place while refraction will not occur. During the process of the reflection, the angle of reflection always remains equal to the angle of incidence. Hence, the rays of light will also reflect at the angle of 50 degrees with the normal as shown in the figure. Next let's focus at point C. At point C, since the angle of incidence again become lower than the critical angle, so refraction of the light will take place at point C. Since, at point C the light is entering in air from water, therefore the speed of light in air will become greater than the speed of light in water. Hence, the light will bend away from the normal while entering in the air from the water. So, the angle of refraction 52 degrees is greater than the angle of incidence 9 degrees at point C. As already mentioned, the details about the change of speed of light in different mediums are explained in our video whose link is given below in the description box. After point C, the human eye receives the light as VIBGYOR colors as shown in the magnifying glass. It is due to the reason rainbow becomes visible to the human eye. Thank you for watching. Please encourage us by subscribing our work.